Hello, in this video we're going to talk about a very basic topic in linear algebra. And this is obviously very important in engineering and it comes up quite a bit, and that is matrix multiplication. So how do you multiply two matrices together? It's very simple, but it can get complicated. But first let's start off with some basics of matrices, because that is important so we have a baseline of what we're talking about. So this is our matrices right here. It's a bracket with just a bunch of numbers filled in. Okay, so these are our rows. These are rows, and then these are columns. Okay, and then whenever you write, so if I wanted to say this is a 3-row by 6 columns, you write it in this annotation. So rows by columns. Okay? Rows by columns. So if I was to tell you, oh, this matrix is a 2 by 3, you should know that it tells you that there are 2 rows and then 3 columns. So we look like 1, 2, 3, 4, 5, 6. Okay, so 2 rows, 3 columns, a 2 by 3. So now that we know that, and these can be any size. It can be a 1 by 7, a 2 by 7, a 8 by a million. These can be any sizes. But this is an important notation to understand, because when it comes to multiplying two matrices, you can use this notation right here to know if you can multiply the two matrices. For example, so let's say I have a 2 by 3 matrix, and I wanted to multiply that by a 3 by 1. Can I do this? Yes, I can, because you want to look at the interior numbers. If they're equal, then check. We can multiply these. If they're not equal, so let's say a 2 by 3 times even a 2 by 3. The two are not equal, so these cannot be multiplied together. So that's very important to know. But this notation also allows you to see something else. So let's say let's go back to our 2 by 3 by our 3 by 1 times a 3 by 1. If these two match, you can think of it as canceling each other out, and you're left with the end result should be, and will be, a 2 by 1 matrix. Okay? So I'm going to prove it right now. And actually I'm going to start with a 2 by 2 so we can more see this clearly. 2 by 2. So I'm going to multiply a 2 by 2 matrix by a 2 by 2 matrix. So first I want to check, can I multiply these together? Yes, I can. The two interior numbers equal each other. And what size matrix am I going to be left with? And that is a 2 by 2. So let's do some math here, and then I'll show you how to multiply these together. Okay, so we have our first matrix with these numbers, and these will be multiplied by our second matrix with these numbers. So again, 2 rows, 2 columns, 2 by 2, 2 rows, 2 columns, 2 by 2. So what do we get here? Okay, so the thing, remember, you want to know is rows times columns. Rows times columns. So we know we want a 2 by 2. So I'm just going to draw A, B, C, D. So we want our A term. Okay, and what's that going to be? This is going to be this row times this column. Okay, so think of it as row 1 times column 1, and that'll give us our 1, 1 point here. So you can see as A this is 1, 1, this is 1, 2, row 1, column 2, row 1, column 1, this would be row 2, column 1, and this would be row 2, column 2. So if we want 1, 1, we want to take row 1 times column 1. And it's not so simple. So to multiply these together, you find the dot product of these two vectors. So you take 1 times 5 plus 2 times 7. And that's our A term. Now we want our row 1 column 2. So now we want B. So we take our row 1 times column 2. So we get 1 times 6 plus 2 times 8. Take the dot product of this vector and this vector. Now we want 2 times 1. Now we want our C in the position 2, row 2, column 1. So we have 3 times 5 plus 4 times 7. And then lastly, we want our 2, 2 spot in our final matrix. We take row 2 times column 2. So we take 3 times 6 plus 4 times 8. Now just do some simple arithmetic, and we get 19, 22, 43, and 50. Now these two matrices are multiplied together. Now if you have a 0 in a matrices, just treat it as a 0. Multiply it by 0. Makes your calculations a lot easier, because 0 times any number is always just 0. So now let's go into a more complicated. Well, it's not really more complicated, it's just a little more tedious. So let's do an example of, let's say, a 2 by 3 by a 3 by 4. So what does this tell us? That, number 1, these can be multiplied together, and number 2, that a resultant matrix is going to be a 2 by 4. Okay, so let's just do this one out quickly. So we have 2 rows, 3 columns. So 1, 2, 3, 4, 5, 6 elements. And if you want to know how many elements, you can simply just multiply these two numbers. 2 times 3 is 6. So now 3 by 4, that'll be 12. So we're going to have 12 elements in this. 1, 2, 3, 4. So 4 columns. 5, 6, 7, 8, 9, 10, 11, 12. So to multiply these, again, our resultant matrix is going to be a 2 by 4. Okay? But if we want our first element, take row 1 times column 1. To be 1 times 1 plus 2 times 5 plus 3 times 9. Now we want our second element up here. Take our first row times our second column. 1 times 2 plus 2 times 6 plus 5 times 10. And now we need 4 elements across the top. So again, take this row times this column. 1 times 3 plus 2 times 7 plus 3 times 11. But now we want to get our second row first column. We can do this, but I'm just going to show you. You now take our second row times our first column. So we have 4 times 1 plus 5 times 5 plus 6 times 9. And then so on. And as you can see, you're going to be left with a 2 by 4. So let's multiply this one. Take 1 times 4 plus 2 times 8 plus 3 times 12. So I'm not going to do all this out, but you can see how the general form takes shape. So it's kind of tedious. Calculators are definitely nice. Using computer programs definitely makes multiplying these things a lot easier. But those are the pretty basics of it, to do it by hand. Let's do one more quick example. Let's say a 1 by 2 times a 2 by 1. And what are you going to get left with? 1 by 1. That's pretty simple. So we have 1 row times 2 columns. So 1, 2, by a 2 row times 1 column. 1, 2, and that just equals 1 times 1 plus 2 times 2, and that will equal 5. Pretty simple.